Hey guys, today we're going to talk about section 3.4. We're going to talk about velocity and other rates of change. Velocity is an instantaneous rate of change of displacement or position, and we're going to talk more about that as we go. We're going to talk about investigating the motion along a line and then applying that concept of a derivative to other forms like economics. Some of you taking econ, you're going to love it. So instantaneous rates of change, we've been talking about this as the derivative for the last few sections. So the instantaneous rate of change of f with respect to x at a is the derivative, and we've written it this way, f prime of a. We're talking about the derivative at a. And then it says provided that the limit exists. Remember, the derivative does not exist everywhere. So example 1 says we're going to find the rate of change of area of a circle with respect to its radius r. Back in chapter 2, I had you do this the long way with that limit definition of a derivative. But now that we've learned the tricks from section 3, we can use tricks. Yay! So for part A, first thing we need to know is what is the area formula for a circle? And if you recall, it's pi r squared. And so here it says, these are our key vocab words. It says the rate of change of area with respect to r. So we're trying to figure out what is the derivative of area. Now we can do this either with a prime, or you can do it with the other notation of derivative of a with respect to r. Okay, or you can just use a prime. I'm going to do this notation. Now, pi is just a number. So if I wanted to find the derivative of r squared, I can just take the number down, and we get 2 times pi r to the first. Now, that's kind of exciting. Anybody recognize what 2 pi r is? I think it's pretty awesome that the change in area is the circumference formula. Kind of mind-blowing, just a little bit. All right, so part B says now evaluate the rate of change of area when r is 5 and when r is 10. So if we were to find a prime of 5, so this is part B, and a prime of 10, we're talking about 2 times pi times 5, so 10 pi, and a prime of 10, 10 times 2 times pi, and 20 pi. So what you just found is the change in area when the radius is 5 and the change in area when the radius is 10. So then part C says if r is measured in inches and a is measured in square inches, what units would be appropriate for dA dr? So think about that one. I'm going to have you ask, it's going to ask a question. What are the units if we're talking about change in area with respect to its radius? So I want you to think about your area is in terms of inches squared. So I'm going to write it out, dA dr. Area is inches squared. And then your radius is measured in inches. So it's inches squared per inch. It's kind of a fun unit. Now, here are some general definitions that you're going to need. We're going to use these all year, so you need to recognize the difference between these three. The first one is displacement, and it's the displacement of an object over time is the change in s. It's how far we've gone from s of t, minus your initial start value. Now, displacement is always with an S, so it's does not stand for speed, but S stands for displacement. So we're going to say if I wanted to know the displacement at time 3, that means we need to start at time 3 and go back to time 0 and see how much it changed. Average velocity, and I want you to highlight, underline, whatever, that word average. When that word average shows up in front of velocity, I want you to think average is algebra 1 slope. In Algebra 1, you did not know derivatives. So Algebra 1 slope, it means you're going to take that displacement divided by time. So we're talking S of B minus S of A all over B minus A. Y2 minus Y1 over X2 minus X1. There are no derivatives in average velocity. Now, instantaneous velocity is a different story. Instantaneous velocity, this is calculus slope. Now we're talking derivatives. So the instantaneous velocity is the limit as our change in t goes to 0. So the notation here is we are going to write s prime of t, or the derivative of s, and that equals v of t, or velocity. And then speed, we talked about earlier in chapter 2. It's the absolute value of velocity. Absolute value of the velocity vector. You can write it as the velocity function. It's also the same thing as the absolute value of s prime of t. Or in our other notation, change in displacement with respect to time. All of those things mean the same thing. So in example 2, some of you may have played around with these motion detectors in physics at some point, but it says a student walks in front of a motion detector that records her velocity. That's an important thing to note. This is her velocity graph at 1-second intervals for 36 seconds. So this is starting at time 0 and ending at time 36. She stores the data in her calculator and uses it to generate a time velocity graph shown in the figure below. Describe her motion as a function of time by reading that velocity graph. When is her speed a maximum? So by looking at this, when her velocity is positive, what does that tell us about how she was moving? Well, from here, I'm going to see that this is broken up 36, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are all 4-second intervals. So I'm going to see 4, 8, 12. So at about time 14, right here, this was positive from time 0 to time 14. And that means that the first 14 seconds, she was moving forward. So then if the velocity is negative, what does that tell us? Well, again, let's see here, 4, 8, I would say for the next 12 seconds, she was moving backward. And then for about 6 seconds or so here in the middle, what does this mean when the velocity is 0? Now she was standing still. And then for that last 4 seconds, she moves forward again. Now, the question was, when is her speed at a maximum? So we are looking for absolute value of velocity. If I make any negative values positive and all the positive values positive, where was the biggest value? And what you should notice is that that's happening right there. So at about time 20, so our max is at time 20. Because speed was the absolute value.